everyone, I'm Jay and today we are going to see different types of switch network. The switch network can be categorized into three types. The first one is the circuit switch network, packet switch network and the message switch network. The packet switch is further divided into two types, which is datagram network and the virtual circuit network. Let's see these types one by one. The first one is the circuit switch network. In the circuit switch network, there will be set of switches will be connected between the sender and the receiver. In the circuit switch network, there is a dedicated path between the sender and receiver. Each connection uses only one dedicated channel. What it tries to say is that in the circuit switch network, if 10 devices are connected to each other, there should be a dedicated link between the sender and receiver. One link cannot be shared for more than 2 devices. Only 2 devices can share one link. If you want to connect one more device, in that case you have to provide one more link. Okay, in the circuit switch network there are three phases. There is the establishing circuit, data transferring and the disconnecting. So if a sender wants to send data, in the first step there is a need of establishing circuit. In the second step there will be transferring of data. In the third step, disconnecting the circuit. This is the example of the circuit switch network. There is a one sender and there is a one receiver. The switch is connected between these devices. You can see that the switch is connected with different devices and it is having more than one input and more than one output, and it is a physical switch. Okay, so when A wants to send data to M, there should be a dedicated link which needs to be created in order to provide the communication. So when dedicated link is connected, after that there is a possibility of the communication will be done. So you can see that in the circuit established phase, there is a dedicated path is provided between the sender and the receiver. After that the communication will be done, and that is known as the second phase, data transfer phase. After the link is provided, after the link is established, the data will be transferred over the dedicated path from the sender to receiver. So the data will be transferred between the sender and receiver. In the third step, after the communication is done, the circuit is disconnected. So what are the advantages of the circuit switching? In the circuit switch, because the sender and receiver is connected via one single link, they can use maximum data rate. Suppose the rate of the link is 10 Mbps, so sender and receiver can transfer data at 10 Mbps because that link is not shared between more than 2 devices. So they can enjoy maximum data rate. So there is no delay because once the link is established, data can be transferred between the sender and the receiver. Okay, so there is no delay after the circuit is established. What are the disadvantages? Like it takes more time to establish circuit. Okay, so because the sender and receiver are far away and because more than one switches are present between the sender and receiver, in the path between the sender and receiver, it gets a little complicated and it takes more time to establish a connection. But after the connection is established, the delay is minimum. More bandwidth is required to set up dedicated channel. Like I just said that in the circuit switch network, if you want to connect 100 devices, there should be a dedicated link between each and every device. So as the size of the network increases, we need more channel, we need more link. It means more bandwidth is required to set up dedicated channels. The second type is a message switching. The message switching is the alternate technique to the circuit switching. Before the packet switching, the message switching was introduced. In the message switching, there is no dedicated path between the sender and receiver. Okay, the entire message is treated as single data unit. So sender wants to send any message, the entire message will be generated and it will be sent. the message is forwarded from one hop to another hop. The store and forward is implemented. Store and forwarded is implemented. What it means? You can see that this is the example of the message switching. There is a one sender and one receiver, and there are different devices A, B, C, D and E. These are the switches. So when sender sending any message, device A will decide that what is the best path in order to deliver the data to device the receiver. So A will analyze the packet, and after analyzing, because A is having multiple options, from this multiple option A will select the best path using which the data will be delivered. So the message will be forwarded to next hop. So that is why it is said that the message is forwarded from one hop to hop, because when the message is received at one particular switch, at one particular hop, it will be analyzed and it will be forwarded to next. Again, when message is received at the device B, it will be analyzed and it will be forwarded. So it is message is transferred from one hop to another hop. What is the meaning of store and forward? Store and forward means when the message is arrived at one switch, the switch will store the message and the switch will analyze the message. After analyzing, it will forward the message. So it uses the store and forward method. Now the question is how the device A or how the switch A knows that what is the destination. So in the message switching, some extra information is added before sending the original message. You can see that in the message switching, extra information is stored in the header that contains information about the destination. So in the message switching, there will not be only the message. Apart from message, there is some extra data which is added before sending the message. So from that extra data, device A or the switch can confirm that what is the destination. When any intermediate switch receives the message, it stores the entire message and forwards. Now, what is necessary in the message switch network? In the message switch network, we need sufficient resource. What if sender is sending very large data, the switch is not able to save? Suppose the storing capacity of the switch is very low. In that case, the switch is not able to store a very large data. It means the part of the data is lost. Because a part of the data is lost, the data will not be forwarded to destination because now the data gets corrupted. So there is a requirement in the message switching that the switch should have large storage resource, large memory. The resource available, then it will forward to the next switch. Now let's see the advantage and disadvantage. The message switch network improves the efficiency over circuit switch. Why? Because in the circuit switch we just saw that if any two device wants to do communication, there should be a dedicated link between the sender and the receiver. In the message switch, it is not needed. There is no need of the dedicated link. The sender and receiver is having multiple link, and whenever any link is empty, the message will be forwarded to that link. So the bandwidth is managed more efficiently. In the circuit switch, the channel is blocked by two ends because at a time only two devices can use the link, but in the message switch it is not possible. It is an advantage, right? It reduces the congestion. The message temporarily stored in the route and it will be forward. That we just saw that it stores and forward the message. In the message switch we can provide some priorities. Okay, like if switch is receiving more than one message, and if one message is having higher priority than the remaining message, so we can define some priority so that the higher priority message can be forwarded at first. What are the disadvantage? Disadvantage is that it requires enough storage. Okay, and it becomes slow if more switching is done. The next one is the packet switching. Now the packet switching is somewhat similar to message switching, but in the packet switching, the data which is to be sent, it is divided into small packets. So you can see that the data is divided into small packets, and those packets will follow the different route to reach the destination. Again, the packet switching uses the store and forward technique. So when any chunk or any packet is received by the switch will store, it will analyze, and it will forward from one hop to another hop. This technique is more beneficial because packet can get discarded at any hop due to some reason. So what happens in the packet switching, that if only small packet is lost, we can get that small packet again. In the message switching, if the message is lost, we have to transmit the whole message again, and there is a possibility that the size of the message is very large. In the packet switching, because the size of the packet is very small, if the packet is lost, we can trace that packet and we can receive the packet again. Let's say example of the packet switching. The host is sending data which is divided into packets, and you can see that the packets are following different route to reach the destination, and it is known as packet switching. The packet switching has advantage that the bandwidth is used sufficient. We can provide some priority to the each and every packet. There is no need of reservation. Okay, the delay is very less. Destination can detect that which packet is missing. Okay, it is fault tolerant, that if packet is not forwarded to particular path, then we can find that in that particular path there is some fault. It is cost effective. What are disadvantage? In the disadvantage, it is not received in the order. The packets are not received in the order. So receiver should know that what is the first packet and what is a large packet. Receiver should be able to rearrange those packets. Okay. In order to do so, we have to provide some sequence numbers. Complexity is more. There are two types of packet switching: the connection oriented and the connection less. The connection oriented, it is known as the virtual circuit. In the virtual circuit, there is a need of establishing of logical path. After establishing of logical path, the data will be forwarded from the source to destination. You can think of virtual circuit as a somewhat combination of the circuit switching and the packet switching. In the circuit switching, we just saw that to provide communication between source and destination, there should be a dedicated link. In the virtual circuit, to send different packets, there should be a dedicated link. So there will be the setup of link, there will be the data transfer, and there will be the end of link. And each and every device will have some virtual circuit ID. Because it is a part of the packet switching, the data is divided into small units and data will be forwarded to destination. Again, it will have some sequence number 2. Datagram circuit, it is somewhat like the combination of the circuit switching and the packet switching. In the circuit switching and the packet switching, now the datagram circuit, it is somewhat like the combination of the circuit switching and the message switching. Like there is no need of establishing of the connection, and each packet will be transferred from source to destination. Okay, how it is different from the virtual circuit? There is no need of the setup connection and tear down connection, and packet delivery is not guaranteed. Okay, so these are the different type of circuit, and I think this is it for this session. Thank you so much.